see if this is going to work or not. Okay, so let's do a question like a homework. Okay, let's do this one. So if you just want to do a game, let's do one of the simpler ones. You want to start? Let's do number 4. This is the number, the thing where, because you're each privately choosing a number between 0 and 5, and then so if you both choose the same number, I'll give you that number times 100. If that number is exactly 1 less than your opponent, so we'll get your opponent's number times 100 plus etc. Okay, so well, if I write this as a game, how many players are there? First, so you and a friend are each probably choosing a number between 0 and 5, and so how many players are there in this case? So you and a friend each privately choose a number between 0 and 5. So how many players are there? No, well, there's 6 strategies, right? But in terms of players, who are the players? Well, it's just you and a friend, right?
Right.
And so there's just 2 players, okay? So I'm going to write down like you or whatever here, okay? And I'm going to write friend up here. So you is the so-called role player, and the friend is the so-called column player. Okay, so you are choosing between what numbers? 0, 1, 2, 3, 4, and 5, right? 6 possibilities. You said. So I'm going to write them down like this, right? So 0, 1, 2, 3. Okay. All right. How about friend? What is the deal with friend? How many choices does friend have? Same, right? So 0, 1, 2, 4, 5. Okay. So sometimes you make it like a little box to make it a little clearer. Sometimes you don't.
Which would make roughly 25 number outcome?
Yeah, I think it's 36, right? Because there's, oh no, yeah, there's 6. 6 times 6, right? 0, 1, 2. There's 6 over here and 6 over here.
I was wrong. That's why I'm not 0. I was looking too much at the 1 to 5.
Oh yeah, that's fine. Okay, so we're already kind of almost half done, right? We wrote down the players, we wrote down the payoffs. Sorry, not the players. We wrote down the players and we wrote down their actions. The next step in writing down this game is their payoffs. So then we just follow the rules. If you both choose the same number, I'll give you both that number times 100. So if we both choose 0, what are our payoffs?
100?
Well, it's the number times 100, right? So it's 0 times 100. So it's going to be like 0, yeah. So I get 0 and you get 0 too. What if we both choose 1?
That would make it 100.
Right, exactly, 100, and then you also get 100. What if we both choose 2? So that corresponds to this thing here, right? I'm choosing 2, you choose 2.
200?
Yeah, 200. I should have moved it bigger. How about here?
300.
300, 300,
400.
400, etc.
500.
Okay, is that clear? Not a big deal. So now it's just a matter of filling out these rest of the things. Now, say that it says what? If my number is exactly 1 less than your opponent's, then you will get your opponent's number times 100 plus a bonus 100, and your opponent will get nothing. Okay, so say I choose 1 and you choose 2. So my number is exactly 1 less than yours, right? So according to this, I get the opponent's number times 100, right? So that's 200 plus a bonus 100.
Right? 300.
Right, exactly. And you get what? And it says your opponent will get nothing, right? So your opponent gets 0. Okay, so what goes in here? This is where I choose 2 and you choose 1. So then what's my payoff going to be? Okay, so this is, if I choose 2 and you choose 1, then you sort of undercut me, right? So your number is exactly 1 less than me. So you're going to get the good thing. And it's kind of like the good payoff, right? So in this case, you'd get what? A 300, and I get the 0. Does that make sense? Okay. How about this one? What if I choose 2 and you choose 3? Then, okay. Then my number is exactly 1 less than yours, right?
That's
so
for every case,
yeah,
right?
right, exactly, right. So then my payoff is going to be what? If you use this rule, right? My number is exactly 1 less than yours, so therefore I get 3 times Was I got 100 times your number, 300. Plus
300.
yeah, then I get a bonus of 100.
400.
Yeah, so 400. And you get what?
0.
Right, exactly. What if I choose 3 and... Yeah, okay. What if I choose 3 and you choose 2? What are the payoffs here, in this case? So I choose 3, you choose 2. So this is the case, this is sort of the opposite case, right? You're undercutting me, and then you...
So it made it 300.
So yeah, it would be, the rule, remember, is you get your opponent's number times 100 plus a bonus 100. Right, so if you do 2, I do 3, I'm like... So you get 3 times 100 plus 100. Does that make sense? Yeah. So this is like 400. And then I get what? So,
Yeah.
right, exactly. Does that make sense?
So,
So in all these cases, in all these examples, you just go through and just kind of do that. Okay. So in all, how about over here? I do 0, you do 1. So this, so remember, you get the bonus if you undercut.
so made it 100.
Yeah. So I get 100 plus the bonus of another 100, so it's 200. Right. I get your number times 100 plus a bonus of 100, so it's 200. This is 0. What goes in here? Now this is where you undercut me.
So made it
So what?
0.
Yeah, exactly.
And 100.
Well, it would be, remember the rule is, if your number is exactly 1 less than mine, then you get my number times 100 plus a bonus, right? So it'll be, altogether it'd be, so it'd be 1 times 100 plus another 100, so it'd be 200. Okay, so you kind of see there's a symmetry here. See what I'm saying?
Yeah.
So then, what about this one? What about if I do 0 and you do 4? So that corresponds to here, right? In all other cases, both of you get nothing. So if I do 0 and you do 4, right, then what are our payoffs in this case? Gonna be,
Nothing.
yeah, both of us get 0. Make sense? So in this game, you kind of gain by doing either the same number as your friend or exactly 1 less than your friend. Okay, that's the idea. So you can fill in these other ones. These are all 0s. So this is 0, 2, I think. And so the way this thing works is you simply kind of just follow the rules to fill it out. So that's what you know, how these things work. So then once you have the game, then you can use like the rules if you did today. You know, like talk about strong domination, weak domination. So that's how to make a prediction in the game. So yeah. Do you want to do another one, or is that okay, or do you want
to? Another one.
Yeah.
So I feel why this is a game because it pretty much is.
Yeah, right.
You're using simple math.
Yeah.
But you're using it in a more logical manner.
Right, exactly. That's exactly right. You're just trying to do. Let's do a really simple one. Let's see. How about?
For now, chess is a little easier.
Sorry.
So right now, chess is a little easier than strategic sport is. Probably because I've been doing it for a longer period of time.
Yeah. It just takes practice. I mean, you just kind of do it and see. Let's see. How about this is number 8. This was the security guard and the thief. Okay. Let's see. So let's see here. Okay, so there's a security guard and a thief. The security guard can either be vigilant or relax. So who are the question is, who are the people involved?
Security guard and the thief.
Yeah, so there's a guard or a den guard. And a thief. Okay. What are the security guard's strategies? What are his policies?
Can be vigilant or relax.
Yeah, vigilant or relax, so write down vigilant.
Or these can either steal or do nothing.
Huh?
These can either steal or do nothing.
Yeah, okay, we'll just write vigilant or relax. Yeah, exactly, you could be vigilant or do nothing. So vigilant or relax. Shut up, okay. Okay, how about the thief? What are the thieves possibly?
Steal or do nothing.
Steal nothing. Oh yes, I'm sorry, that's what you said before. Okay, so this is it. Now the next step is to do what? What do we have to fill in now?
In this case, it's a guard relax.
Yeah, the payoffs.
Thief would steal.
Yeah, exactly. Okay, so how do you fill these out? So it says if the guard is vigilant, then the thief would rather do nothing than steal. Okay. So how we write some numbers in that, like if the guard is vigilant, the thief would rather do nothing than steal.
So the numbers are of our choice.
Huh? They're silly?
The numbers are of our choice.
Oh, yeah,
So
by
we
choice.
have 0 and 1.
Yeah, exactly. Exactly right. So the numbers are going to be up to you in some sense. So if the guard is vigilant, we said that the thief would rather do nothing than steal. If that makes sense. So let's put the thief's payoff as like, I don't know,
1.
1 here. What would be the number here then?
0.
Yeah. Okay. That's fine. Makes sense. And then we says if the guard is relaxed, however, the thief would rather steal than do nothing. Okay. So if the guard is relaxed, the thief would rather steal. So what would be the payoffs here?
0 and 1.
So what would be this thing? So if the guard is relaxed, the thief would rather steal. Do you think it should be 1 here, or is it
I would probably be negative 1.
negative 1?
Yeah.
Well, I think actually this might be the best thing for the thief, right? Is for to have the guard relaxed guard, and therefore he wants to steal. So I think I would make this what I would make this a 2.
Oh.
Something like that. Okay. How about this? Now what's the payoff here? This is where the guard is relaxed and the thief does nothing.
Then there's probably should be 0.
Yeah. Okay. Yeah.
He is neither paid nor lost.
Yeah. Okay. Okay. That's fine. All right. Good. So let's see. Okay. Now what about? So we did the thief's payoff. What about the guards? Okay. What does it say? If the thief steals, the guard would rather be vigilant than be relaxed. So if the thief steals, what's your number should we put in here?
Would probably be 2.
Right up here?
Yes.
And now here?
0.
Yeah, exactly. So the thief would like to be, the guard would rather be vigilant if the thief is going to steal. Okay. However, if the thief does nothing, the guard would rather be relaxed than be vigilant. So if the thief doesn't do anything, the guard wants to take it easy. So what would be the payoffs here, do you think?
1
Okay.
and 0.
0? Well, remember he says if the thief does nothing, the guard would rather be relaxed than vigilant. Right? So it's saying that if the thief does nothing, the guard would rather be relaxed than vigilant.
So that would probably be reversed, right?
Yeah, exactly. Okay, let's do that. Yeah, maybe 1 and 0 like this. Does that make sense?
Yeah.
So in here, the best thing for the guard is to be vigilant when the thief steals, because I guess then he gets the glory or whatever, right? Maybe what's the worst thing for the guard?
To be relaxed and have it steal.
Yeah, exactly. So maybe this 0 should be like a -1 or something. You can make that. I don't know, whatever. But anyway, so that's what you do when you do these things. So that's mainly what you missed. I mean, that's mainly what the homework 1 is all about, is this stuff. So in homework 2, you'll be you'll be doing the same thing, but then you'll take an additional step of trying to make a prediction too. So that's what we talked about today in class, is the part about domination. So you use strong domination, weak domination to make some predictions.
Also, during the first lecture, I reviewed the notes from Korea here to get a little better understanding of the strategic form game.
Sure.
When it came back to this lecture, I finally understood it a lot more.
Okay. Sure. Cool. All right. Yeah. Yeah, and also you might want to just ask somebody else in the class for notes or something like that. Oh, I also put the slides up too. Did you see that?
Yeah, I was looking at them during the lecture.
Okay. Yeah.
So I was looking at Tuesday's slides and today's slides at the same time.
Okay. Cool. All right. So let me know if you have any other questions or something, but I think that's more or less what we did. So the first little bit was we talked about, simple model of individual choice, and then how to write down the strategic form game, and now we're going to talk about predictions.
In a way, the class revolves around making decisions and the consequences of these decisions.
Yeah, exactly.
How do I view of life?
Oh yeah, that's true. It does it. Yeah.
It's all about decisions.
No, it's absolutely. That's why people. Well, that's why I like this stuff, is because there's a lot of applications like that, even to everyday life. So.
Maybe that's why it shows his class.
Huh?
Maybe that's why it shows his class.
Yeah, I do. That's why I like this field. Yeah.
Math is kind of like kryptonite on the side mission, but
Oh, okay.
I need to restart my math courses in
Oh, I
order to
see.
stay in science.
I see.
But I feel sick primarily because at first the mathematics threw me out a little,
Right.
but when I look at it, it's more of an actual
Right.
game
Right.
and more of a teaching of life
Right.
than it is a math problem.
No, exactly. That's exactly right. The math in this class is not particularly difficult. It's more just about like using the numbers to talk about, like real life situations. I mean, there is part of game theory which is very mathematical and technical, but that's important. But this is actually the core of the field, is right?
Yeah, it wasn't 0 through 9 pretty much.
Right.
You could use what you know of arithmetic and manipulate the numbers.
Right.
The rest of it is physically manipulate the numbers
Right.
and see which are best outcomes
Right.
to have.
Sure. Absolutely. So, yeah. So, anyway, yeah. So, yeah. I mean, that's why I like the subject.
The whole chess is as well. Even though chess is you want to know pieces, you want to know how you move, and sometimes you know a special move,
Right.
it's still what is the best outcome per piece.
Right.
If I move this piece here,
Right.
what will that affect my future play
Right.
when my opponent moves his piece somewhere else,
Right. Sure. Absolutely.
or attack my piece, which will lead me to make decision A, B, and C.
Right. Absolutely. This class is all about that. Exactly.
Yeah, I hit the right class.
Oh, very good. Okay, great. All right.
Mm-mm.
Okay. So this is your first year at UCLA?